Okay, the last thing that we're going to talk about nomenclature-wise is how to name acids. And how can you recognize an acid formula? Well, they all begin with number one. They all begin with hydrogen. Okay, but there are different rules for the different types of compounds that begin with hydrogen. So there are two different types of acids, and the rules for naming them depends on which type it is. So there's a hydroacid, which is hydrogen bonded to a monatomic anion, which is somebody from set 4 of the gold ion sheet. That's essentially just saying one of the elements. Okay, one of the nonmetals that we have over on the right-hand side of the periodic table. So that would be a formula that just says HCl or HF or H2S. No, it doesn't matter how many hydrogens there are. We'll get into that with formula writing, okay? The other type of acid is an oxyacid. Oxyacids are hydrogens bonded to our polyatomic ion friends from set 5 and from set 6 of our gold ion sheet. They contain more than one capital letter as the anion. So it's H and like an NO2 or H3PO3. So those have a very different set of names to them. So let's do the first one. The first one is the hydroacid. So H bonded to an element. The way that we name it is by using hydro, the base of the element name, then we change the ending to ic acid. And acids are kind of icky to get on your skin, so I would say ick, it's an acid. Okay, so HCl. Cl is chlorine. So I'm going to change the ending to ic. All right, and we add the prefix hydro. So this is hydrochloric acid. You've heard of hydrochloric acid before. HCl are actually the initials of my third child, Harrison Cade Levin. Yes, done on purpose. All right, HF. Okay, F is fluorine. So we're going to change the ending to fluoric. So add your hydro in there. Hydro, fluoric acid. And remember, it's a UO like the flu instead of flour, Flour. Fluoride. Fluoric acid. All right, H2S. S is sulfur. So we're not going to make it sulfic or sulfuric. We're actually, English is super awkward. We're just going to add the ic right to the end of it for sulfur. So you might want to put a little star next to that one. So it is hydrosulfuric acid. And then lastly, we have H3P. P is going to be phosphorus. So we're going to change that and make it phosphoric. So hydrophosphoric acid. All right, so the hydro prefix means it's just going to be H and an element. And please, please, please remember to add the word acid when you are naming acids. A lot of people miss that half a point or so because they forgot to put that in there. So again, HCl is hydrochloric acid, HF is hydrofluoric acid, H2S hydrosulfuric acid, H3P hydrophosphoric acid. Now, when it comes to naming the polyatomic ion acids, you gotta recognize the name of the polyatomic ion. All right, so if the polyatomic ion ends in ite, we're going to change that ite to us acid. There is no hydro prefix for any oxyacids. Okay, so HNO2, you have to recognize the NO2 as nitrite, and then we change the ending to us acid. If the polyatomic ion ends with an 8, however, that's where we change the ending to ic acid. So HNO3, you need to recognize the NO3 as being nitrate. And then you can change the ending to nitric acid. So to help you with this, I don't want you to get too stressed, okay? Because do you know what stressed is backwards? That's right, desserts. So I want you to think of your favorite dessert, okay? You thinking of it? I happen to like strawberry shortcake. If you take a bite of your strawberry shortcake, you will think to yourself, this is delicious. This is just what I need. I'm so stressed out. But if you were to eat the whole thing, you would get very sick and ill. Blech. Okay? So this will help you with your polyatomic ions. I took a bite. It was delicious. I ate the whole thing. I got sick. So this is where we're going to use our endings to help us out. Okay, so if you need to jot it down, write it becomes us. I took a bite, it was delicious. And I ate the whole thing and I got sick. So it becomes us's, ate becomes ix. All right, so H2SO3, you have to recognize the formula SO3. SO3 is sulfite. I took a bite, so this becomes sulfurous acid. Sulfurous acid. So fast, so sulfurous acid. Haha. H3PO3. This is phosphite. I took a bite, it was delicious. So this is phosphorus acid. Okay. H2SO4. SO4 is sulfate. I ate the whole thing, I got sick. So this becomes sulfuric acid. And then lastly, we have our PO4. So this is phosphate. So this becomes, I ate the whole thing, I got sick, phosphoric acid. All right, so ites become us's, ates becomes ix. I took a bite, it was delicious. I ate the whole thing, I got sick. So a phosphite becomes a phosphorus, a phosphate becomes a phosphoric. Now, when you go to write the formulas, okay, you are dealing with acids, and all acids have that donatable H+. So we are going to begin with that, and then you just look at the name, okay? So if it says hydro in front of it, just use that monatomic ion from set 4 of your periodic table. So hydrofluoric acid means that I have H plus and I have fluorine, which is fluoride, F minus. Then we do what we do best. We crisscross and we make a bond. So H plus, F minus makes HF. Okay? Hydronitric acid. That's H plus, and nitrogen, nitride, is an N3 minus. So I'm going to crisscross here and need H3N in order to get that. Okay, hydroiodic acid comes from iodide, H plus, I minus. And when you put those together, you recognize that your 1 plus and your 1 minus cancel out, and you get HI. Okay, so you can say, hi hydroiodic acid. If you are writing your formulas for the other ions, okay, with your polyatomic ions, you do the opposite of the desserts. but you can use that Hydroacidic tool. Okay, so nitrous acid. Nitrous means it comes from nitrite. So if you have to write down nitrite, that's okay. H plus and then nitrite, NO2 1 minus, and then the 1 plus cancels out the 1 minus. We get HNO2. Sulfuric comes from sulfate. So this is sulfate as my root ion. So H plus and then SO4 2 minus. And then make sure you crisscross correctly. You need 2 hydrogens to cancel out that 1 SO4 2 minus. And then lastly, we have our acetic. Ic comes from 8, so acetate, acetate. So that's H plus, and then C2H3O2, 1 minus. Remember, we know those charges. 1 minus, 1 plus. This is HC2H3O2. So that is acetic acid. Don't write the H in here. That tends to confuse people and you might not recognize it as an acid. Okay, you might see it written this way, CH3COOH as a carboxylic acid. This is vinegar. You might have seen the other one in your bio classes, but all acetic acid is vinegar. Or, as one of my former students famously said, Miss Avin, what's Vinegar? I've never heard of a Vinegar chemical. And I said, vinegar? And then they felt really kind of silly about that. But hey, we're here to help you not make silly mistakes anymore. Okay, so make sure you know your ions. I cannot stress that enough. We use the crisscross method all the time, and we will in future chapters. So ions, 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 and more ions. Got it? Good.